Part 2. Part 2. Again, rules for logs. I'm going to throw that up here so we have it. We got rewriting. We got condensing or maybe expanding. Rule 3. Change a base if we need to do that. We're going to need to do that in this problem. We can, if we have 2 logs on each side, we can cancel them out and get 2 things. Or if we have things that need logs, usually when x is in the exponent, you can put logs on both sides. I did that at the bottom here. X in the exponent on both. I could put logs on both sides and use rule 3 to take them down. And then some quick hitters here. I covered this more in the first part of the video, so you can go back and look at that. We're going to do problems on the 7-4 notes, 5A and C, 6B and C, 7B, C, D, and 8A. Let's crank those out. These are going to be fun. Oh, I could use a drink right now. I need a water. My throat's going, ah! But here we go. All right. How many logs do you see on 5? I see 3 logs. I can't have 3 logs. Now, if I had 1 log, I could rewrite. That's typically the case. But if I have if I have it like this, cover that up. If I have 1 log on either side of the equal sign, I could just cancel them. Okay? Maybe I should do number 6 first. Do number 6. Look at that. I got 1 log on each side. I can just cancel. Oh, I can't quite cancel them. I have to do rule 3. Bring that 2 up there, and I get log 5 squared, so 25 equals log x. Now you have 1 on each side. Oh, yeah, chop on the log. Get rid of that. X is 25. 5 squared. So if I can get 1 log on each side, I'm cool. If I don't have 1 log on each side, then I'm not cool. Okay, I got to clean. So I'm not cool up here. So what can I do there? Well, I can use rule 1. Rule 1 said, hey, when you add, you can multiply those numbers. So this is log base 2 of 5 times 8, 40, log base 2 of x. Now some people say, oh wait, 8 is 2 to the 3rd. You can cancel out and put a 3. That's not going to help us. But now I have 1 log on each side, so I can say chop of the log. Okay, I want to hear that. And so, oh yeah, x is 40. Ooh, booyah, pretty easy. So condense it and get it together. And okay, this one will be the same. It just condense those 2 things, get it together, and then solve. Let's do this one because it has a minus. 3 different logs, so we got to condense something to get it down to 1 on each side. Minus means division, so log 3 of 20 over x, divide that, equals log 3 of 5. 1 log on each side, gonzer. So 20 over x equals 5. Now, just having that, I know x can't be 0. Got to leave that out. But multiply both sides by x, so you get rid of that. 20 equals 5x. Divide by 5, and x is 4. Plug it back in. Make sure it works. Should work. Okay. Jumping down. If I go too fast, just pause and rewind. So here we go. This one's the same. B is the same as A, but you see the ln, so you got to think of an E. We're just going to take, oh, let's go purple. Take this 2 and move it up here. Take this 3 and move it up here. So we get ln of x to the 2nd power and ln of 4 to the 3rd power. Okay, so the numbers in front become exponents. Exponents become numbers in front. I have 1 log on each side, natural log. Cancel them out. I get x squared equals 64. That's 4 to the 3rd, 64. I'm going to take the square root, putting a plus minus like a dutiful person here. I get x because this cancels, and I get plus or minus 8, and so my answer is 8. Why? Because negative 8 I had to get rid of, because I'm not allowed to do the natural log of a negative number. Now you say, wait a minute, you moved that 2 up and made it squared. Yeah, but still, if you try to do it from the original problem, 2 ln negative 8, it says, no thank you. All right, jump over to C. I don't know why I did A. Maybe because it was easy. see. I don't think I did this one in class, but this one's kind of easy. I did do this one. We can move that 3. Oh, I used green. Move that 3 up. Log base 4 of x to the third equals log base 4 of 27. I'm going to give a shout out to Henry because I know he's watching this right now. Okay. One log on each side. Going to cancel that. Pretty sure Jason is watching this right now. Maybe Savannah. Okay. Bunch of others. A bunch of Caitlin's probably watching. Ashley's probably watching. If you're watching, just put a comment in there and say, hey, I'm watching. Love to see the comments. But those cancel. X to the third equals 27. If I don't know you, then shut up. I don't want to hear you. No, just kidding. I'm just playing. This is for my class. Now, how do you solve that? Well, if it were squared, we'd do square root. Just solve that square root. It's cubed, so we can't do square root, but we can do cube root. Hello. So this would cancel out, and we get x. What's the cube root of 27? 3. 3 times 3 times 3, 27. Boom! I need a drink. No pausing. Crank it out, right? Right? I can't pause. Ashley would be mad at me. Okay, here we go. What do we do? What do we do? What do we do? Oh, yuck. All right, so I know right away, boom, 2 log 5. Ah, I can move the 2 up there. I can move the 2 there. Log, can I just put 25? 5 squared. Okay, 5 squared. All right. But here, 2. That 2, yuck. That 2 is messing me up. It's not a log. Now, Erwin would have you believe that you can take that 2 and write it as a log, and all would be fine. And he's absolutely correct. It's just weird. What I would tell you, how about we take this log and subtract it so it's over there with that log? Huh? So now I'm going to write 25 minus log x equals 2. Now, how about I use rule 2 with the minus to make this log of 25 over x equals 2. What's the base? What's the base? Base 10, because I didn't write it, right? See, the base is always written right in here, and there's nothing written, so we got to assume it's a 10. So now I can rewrite. I have 1 log. Boom, I can rewrite. So I would write 10 to the second power equals 25 over x. And we're going to have to squeeze up some room here. Don't know how Graham does this. So we come over here. 10 to the second power is 100. I'm going to go ahead and multiply both sides by x, so I can cancel that out. Bring it up here. I get 10 squared, which is 100x, equals 25. Divide by the 100, you get 25 over 100, which reduces to a quarter. Is that okay? Sure it is. You can have fractions. You can't have negatives. Negative x in there, no good, but there we go. So I get the logs together and leave the constant by itself. Use one of my rules to combine the logs, so I have 1 log, and now I can rewrite. I think that's the best method to go. There's other ways to do it, but it gets confusing. 7C. Like your brain. All right. God, look at that. The constant over here. The constant. So that constant throws me off. I can't just chop logs. I like log chopping. Helps me sleep. Okay, so combine this. Plus means times, so we got log of this times this equals 3. What's the base? There's a 2 in there. I have 1 log now and a constant. Let's rewrite. Rewrite. Okay, base of 2 to the third power equals x times x plus 2. Now, you can't see it. You can't see it, but I'm going to cross it out. Cross out. The x times x plus 2, if we distribute it, it's x squared plus 2x. Oh, I got an x squared. If I have an x squared, I get it equal to 0 and factor. So I'm going to take this 2 to the third, which is 8, and I'm going to subtract it over there. I got 0 equals x squared plus 2x minus 8, because 2 to the third was 8. Now, either quadratic formula or factor. I'm going to go factoring because I know it goes plus 4 minus 2. And so x plus 4 gives me negative 4. And x minus 2 gives me positive 2. And the negative 4 goes in the trash because I can't do the log of a negative. So x is 2. Woo woo! Oh, I know you're laughing right now. Don't laugh. Don't laugh. Make a comment. It'll be fun. So I had the two logs. I combined them together. I can distribute that. I did over here. Then now I have one log with a constant, and so I could rewrite base to the power equals this. 2 to the third. I should probably just write 8, but I wanted to kind of show it. Because I have an x squared, I try to get it all on one side and factor or quadratic formula. Boom. Let's go over here. D. We're starting to get into the fun stuff. I did this one. I was so excited. Breathe. All right. I'm going to use green. So I have 3 different logs with an x. This x is similar to a constant. My goodness, this by itself. But I want to combine all this stuff. And in fact, I combined all this stuff. I'm looking at it now and I'm kind of like, how stupid are you? Right? Do you see a single x in this entire side? No. Ladies and gentlemen, what a moron your teacher is. Log base 4 of 2 plus 2 log base 4 of 3 minus 1. Oh, that's the wrong button. That's the 1/2. You watching me? Dada boom log of base. No, not that log. I want that log. Base 4 of 36. See, I could everything. All the numbers are over there. I can just type them in, hit equals. I'm done. What a beeswax. 1.79. I'm going to write that over here. X is approximately 1.79. Now, here's what I taught in class. Got some good skills with it. Okay, but I didn't need to do it because everything, literally everything, Trick or Rudy, I just saw it now. All that stuff. There's no variable over there, so I can just type it in the calculator. What am I doing? Okay, I'm gonna do some work. I can move that, I can move that, and I can move that. All the numbers 3, 2, 1/2, they can become powers. Okay, so log base 4 of 2 to the third plus log base 4 of 3 squared minus log base 4. Now, 36 to the 1/2 means square root. Okay, I'm going to write that down. 36 to the 1/2 power is the same thing as square root. I don't like the 1/2, I do like the square root. Now, 2 to the third, that's a 3. 2 to the third power is 8. 3 squared is 9. So let me just kind of throw this in here, 8 and 9, right? And if we're doing addition, that means we can multiply those. So we can go log base 4 of 72 minus log base 4, square root of that is 6. Now, 72, the minus means we can divide. 72 divided by 6 is 12. And so x is that. And so remember, we got 1.79. Watch what happens when I go log base 4 of 12. Same answer. Okay, so just some skills that, hey, numbers in front become powers. I can condense it down into one single log. That's great. But when I look at it, it's like, golly gee willikers, I could have just put that all in the calculator with one shot, not even doing any work. Huh. Thanks, Mr. Bone. All right, here we go. Issue. This is base 2. This is base 4. You can't just cancel the logs when they're different bases. You have to change them. The only way to change them is to do change of base, meaning you go log of x minus 2 divided by log of 2. And then you go log of x squared minus 6x plus 26 divided by log of 4. And that's where we're stuck. Now, Okay. The key for me was the 2 and the 4. They're related to each other. You see, I can change the 4 into the log of 2 squared, because 2 squared is 4. I saw that in my head. It took me a while. I saw that in my head. It's like, wait, now I have a log of 2 and a log of 2. I got 2 log of 2s. But even more, Rule 3 says I can take this 2. Let's go blue. I can take this 2 here and bring it in front and put it there. Okay? So now I have 2 log 2 and log 2. If I take and multiply 2 log 2 to both sides, multiply it to both sides. On this side, 2 log 2 and 2 log 2 totally cancels out, and I'm left with the log of x squared plus 6 minus 6x. That's a minus 26. That's a minus, trust me. But over here, I have this here. What do? Well, look, log 2 and log 2 can cancel out. So I'm left with 2 times the log of x minus 2. But this 2 in front can become a power, so I'm left with the log of x minus 2 squared equals the log of x squared minus 6x plus 26. And now I have 1 log on each side. So different bases, I got to do change of base. It helped that this base here I can change to 2 to the second power, move the 2 in front, multiply both sides by that, so it cancels here, and the log 2's would cancel. I do have a 2 here that became an exponent. Now, 1 log on each side can go away. I'm going to multiply this out. It's x squared minus 4x plus 4. Okay, do a box if you want. Over here I got x squared minus 6x plus 26. I'm going to do this right this time. If we subtract x squared to both sides, boom, boom, cancels. Gone. Beautiful. Don't have an x squared, don't have a factor. If we add 6x to both sides, boom, boom, we get a 2x. This becomes 2x plus 4 equals 26. If we subtract 4 to both sides, bonk, we get what? 2x equals 22. So x is on, say. That's crazy. So 2 different bases do change a base. This worked out nice because now that base could be rewritten as 2 to the second power, move the power in front, then multiply it to both sides so that this will cancel out completely here, and here the log 2's cancel. This 2 becomes a power. Now I have 1 log on each side, cancel the 1 log, multiply this, add like terms together, x is 11. Wada, wada, wada. All right, 1 problem left. I promised I would do it, and I didn't do it. I promised. Now, this one here. All right, last one. How much time I got? Not much. This one's special. Okay, let's focus in on this e to the negative x. That e to the negative x could be written like this. Negative powers mean fractions. Now, I think of it that way. I can multiply both sides by e to the x to get rid of this here. So now distributing, I got e to the 2x, because it's e to the x times e to the x, e to the x squared, or e to 2x. Okay, add the exponents. Plus 6e to the x equals 5. I'm going to subtract the 5 over, so I get equals 0. Now we can factor, right? Except factor 1 and negative 5, 5 and negative 1. It won't factor. I mean, it looks like this problem, but this won't factor. Like that one I can substitute because it'll factor. This one won't factor. Okay. Well, think of the e to the x as a variable again. Let's get a piece of paper here. Think of e to the x as a variable. Think of this as like x squared plus 6x minus 5 equals 0. It won't factor. What do? Yes, sir. Quadratic formula. Quadratic formula. Remember that right there. Okay, but instead of x's, what do I have? E to the x's. So instead of an x, I have an e to the x equals all that. Yikes. Son of a biscuit. All right, here we go. E to the x equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. So e to the x is going to equal two different things. Here we go. Calculator. Put this in here. We can do this. Not so bad. Negative 6 plus square root. 6 squared is just 36 minus 4 times 1 times negative 5 all over 2 times 1. The first answer will be negative 3 plus the square root of 14. I don't like it, but I'm going to stick with my wanting to have the most accuracy possible. The second answer, I already know, will be negative 3 minus. If we go back, delete minus, change it to the negative part, we get negative 3 minus square root of 14. Now, I already know this one is going to be not possible because, well, negative 3 minus something is still negative, so it's going to not work. But we would do a rewrite. Let's go blue. Base is e, so ln of negative 3 plus square root 14 equals x. This one would be ln of negative 3 minus square root 14 equals x. Remember, the base is e, so that's where you get the ln, and the x is the power, so that goes on the equal part. I'm getting the best answer here possible because I did not round anything. ln negative 3 plus square root 14. Okay. Negative 2.99. X is negative 0.2. No, yeah. Negative 0.299. Now over here, if I just go back in and delete and put a minus, math error. This one's not possible, so I can just so it's negative 2.99. So yeah, that was a quickie one. I wouldn't worry too much. I mean, yeah, you gotta hopefully try to solve these ones in your homework. I give it to you. There you go. Good luck. Send me your comments. We'll see you Monday.